Please note, in sections that contain many indices, we will skip saying sub. For example, in this section, I will say AI instead of A sub I, XI instead of X sub I. Here is a totally different approach for the Simpson's rule. Simpson's rule is approximation of the area of a region using parabolic areas. Here is a subdivision, and let's see what happened to the interval between xi minus 1 and xi plus 1. Here is approximation by parabolic area. Let's now focus on a sub I, because whatever is done here, this is just arbitrary xi, is true to all the others. To find the area a sub I, we are moving it so that xi equals to 0. This is just going to be much easier. Because xi is 0, we get that because xi minus 1 is xi minus delta x, this is negative delta x. And because of the same reason, this is delta x. And the middle one is now going to be just 0, which is xi. The approximation now is using kind of the fact that because we have curves here, then a parabola is much better approximation than just trapezoids or straight lines between the points. To find the area AI, we have to approximate the integral between negative delta x to delta x of this parabola. Because we assume that this is a parabola, we can say that this curve, the purple curve here, is y equals ax to the power of 2 plus bx plus c, and that's why we want to integrate that between negative delta x to delta x. Here's the antiderivative. And now we will substitute delta x and then negative delta x. And we get 2a over 3 times delta x cubed plus 2 times c delta x, which can also be written like that. Let's see. This is f of x minus 1, which means that this is f of x minus 1. It means that this is f of xi because it's the next one. And then we have f of xi plus 1. What we need is the 3 coordinates. We need this coordinate. This is the coordinate that has x value of negative delta x and y value of f of xi minus 1. Here the x coordinate is 0 and the y coordinate is f x of I. And here the x coordinate is delta x and the y coordinate is f of x I plus 1. We are going to use this to find the equation of the parabola. We know that the parabola is passing through the 3 points above. So now we are going now to substitute this in here. First we substitute f of xi minus 1 for y, and then x has to be negative delta x. Then, for f of xi, x equals 0. And when y equals f of xi plus 1, we substitute for x delta x. From here, it's already clear. What is c? C is just f of xi. Let's now try to do something here. Let's add up f of xi minus 1 with f of xi plus 1. You can see that b times delta x is cancelled out, and we get that f of xi minus 1 plus f of xi plus 1 is 2a delta x to the power of 2 plus 2c. Now I recall that this integral is just delta x over 3 times 2a times delta x to the power of 2 plus 6c. I'm going now to break down the 6c to 2c plus 4c. You will see why in a second. This is exactly that. And this is exactly c. So let's now replace the yellow by f of x sub I minus 1 plus f of x sub I plus 1, and we replace the c by f of xi, and we get this. I'm rewriting, just shuffling the order, because I would like that first we will have the f of the lower index, then f of xi, and then f of xi plus 1. And we get that. But now let's start from a equals x of 0. I minus 1 and I plus 1 are odd indices, and I is an even index. It means that if you look at the first area, ai minus 1 and ni, then if you see the yellow big dot, it appearing twice. And this guy appears only once. This appears only in ai. This is this one. But those two, if you pay attention, those guys are odd indices, but they are appearing twice. Once they are appearing in ai, and once they are appearing in ai minus 1. It means that this is going to appear 2 times, and this is going to appear 2 times. Except the first one, except fa, all the even indices are used twice, 1 time in each area. All odd indices are used only once, 4 times in each area. In this one, except f of b, all even indices are used twice, 1 time in each area. So when we sum all the areas, and the integral is between a and b, not just between negative delta x to delta x, we actually get the following. F of a is appearing only 1 time, and then we have f of x1 4 times. It appears once, but times 4, and then 2 times, and then 4 times, 2 times, 4 times, 2 times, and the last one again, only 1 time. And again, we get exactly the same Simpson's rule.